Hello? Operator? Yeah, there's been a disaster. I need you to get me something that can fly around, take a look around. I need it as soon as possible. Hello, this is HQ. Right, understood. I'll start printing one out for you immediately. Should be ready within a day. Right, thank you. Hi, and welcome to the Design Day video presentation for Project 19079, Print on Demand Robot, or PodBot, sponsored by Raytheon. From the left, we have
Woody Jackson, Mechanical Engineering.
Michael Fell, Electrical and Computer Engineering.
Aiden Spolstra, System Engineering.
Jahao Deng, Electrical Computer Engineering.
Nathaniel Pott, Mechanical Engineering and German Studies.
Tuan Trung, Mechanical Engineering.
So this project is the development of a system that allows an end user to quickly respond to an evolving or kind of sudden mission need or requirement. It consists of a graphical user interface with part databases and designs, a 3D printer, and a kit of commercial off-the-shelf or prefabricated parts. So the user is able to be presented with some sort of need and very rapidly respond using a tailored robot or drone for that application, instead of having a very significant supply chain to be able to keep them updated or supplied with vehicles to cover a wide range of mission requirements.
Drone configuration is selected based on a specific mission need. The PodBot operator will use the GUI part selection to select the appropriate configuration, which will then be sent to a 3D printer for printing. Once printing is complete, the 3D printed parts as well as a kit of commercial off-the-shelf parts will be used to assemble the new configuration. And then this assembled PodBot is ready for deployment in the field. From the time that mission need is determined to PodBot's deployment in the field, the total time is expected to be 24 hours.
A quick guide to the GUI of PodBot. Here we have the homepage, which introduces the team members, sponsors, and mentors. The informational page, which gives assistance to the end user in various ways. The parts page, which allows the user to traverse all parts tested and supported. And finally, the builder page, which allows the user to specify particularities to a drone build, resulting in a list of affiliate parts.
For the design material, we'll be using ABS for our material due to its high tensile strength and is very resistant to physical impacts, which allow the finished plastic to withstand heavy use and adverse environmental conditions. Cost part, we'll be getting it from hobby and robotics vendors such as Vex, Amazon, etc. For modeling, we will be using SolidWorks to design the UAV and UVG and the core. For flight control, we'll be using iNav.
So here are some of our project's results that are related to the system requirements. The UAV was printed, and its assembly, as shown in the assembly time lapse, took only about 40 minutes, and that was with a few mistakes that had to be corrected. Our models and analysis show that the batteries are projected to last at least 19 minutes, and our UAV design takes a total of 13 hours, with 9 hours to print the core and 4 to print the carriage and motor arms. The UAV original print time was about 30 hours. Our UGV design takes a total of 25.5 hours using the same core that takes 9 hours to print. The original UGV design had a print time of about 55 hours. The UAV design was capable of lifting a half pound of payload, and our UGV design could support 25 pounds of payload without structural damage. Our UAV cost came out under $500, while the UGV exceeded our $500 cap and was just under $700. This is due to the cost of the components required to create a sturdy and reliable bot that can print in about a day.
So after many design iterations, although we got our print time down to around 24 hours, especially for the GroundBot, we are still recommending 2 printers for the user to make sure we hit that 24-hour mark and optimize their print time. Another thing with the printing we realized is that the 0% infill is ideal for printing because as you add infill, it doesn't really add structure to the print. So unless we're using up to 50 or 0, it doesn't really matter. The only reason I'd use infill lower than 50 for non-structural would be to have supports for top printing and stuff like that. Also, we had a design trait for cost versus time. It came out really heavily in the GroundBot when we had to decide to buy wheels and stuff versus printing the wheels. Again, it costs more for the bot, but it allowed us to have that lower print time and also more rigidity and stuff for our design.
This is a version 4 of the design. The overall design haven't changed much from the previous, but again, due to print time constraint, we decided to cut down some parts. And by adding iso grid structure to the side of the chassis, it will have better support and empty space to reduce print time. Top and bottom piece to support the rigidness of the bot while hold the core in the center place.
So we can see here the third iteration of the quadcopter carriage and motor arms, going from a kind of a larger, chunkier design, multi-part, to this very slim half-inch triangle, isosceles triangle design that allows it to interface very neatly with the core. The core having this open grid on the top that allows the user to put electronics wherever they need to. The center portion is reserved for a flight controller to keep it over the center of mass, but this design allows the end user to select whatever electronics they have on hand or are best suited for their situation, as opposed to a pre-constrained kit. On the bottom, you can see the bay for the 2 6,000 milliamp hour batteries. And then this is the lightweight version of the UGV. You can see the springs on the front and the rear, which are designed to both reduce the print time and to automatically tension the belt when a load is applied. This design has a slight flaw where it needs to have a rigid structure connecting the front and rear springs to avoid camber from the wheels due to the bending moments resulting from a weight at the center of mass. This is the weight test for the lightweight ground vehicle. And the initial mission requirement called for an ammo supply vehicle for a SWAT team pinned down in the city. And so here we can see it with 2 .30 caliber ammunition cans. Thank you, and hope you enjoyed our presentation.